This is 7.3, Simplifying Algebraic Expressions. Before we can get to actually simplifying the algebraic expressions, there's a couple things that we need to know. So in order to add or subtract terms, they have to be like terms. Well, what are like terms? They're terms that have the same variable raised to the same exponent or the same power. What we also talked about was that all constants are like terms. So 5 and 9 are like terms. -3 and 100 are like terms. Because remember, constants are numbers with no variable. We also need to talk about, well, what does it mean to simplify something? Well, when we're simplifying something, we're just making it less complicated. So here I have an example, 19x plus 13r minus 5 plus 24 minus 9x minus 7r. This is a lot of addition and subtraction happening. So what I did is I went ahead and I simplified this expression, and I got 10x plus 4r plus 19. This is a lot less complicated than this. And so that's what we're going to be doing today. We're going to be simplifying expressions. So here we have w plus w plus w plus w plus w plus w. There is a much easier way to write this. Remember that in front of each variable, if I see no coefficient, my coefficient is a 1. So here I have 1w plus 1w, that's 2w, plus another w is 3w, 4w, 5w, 6w. When I simplify this, I get 6w. 6w is it's less complicated than this would be. Here I have -r plus -r plus -r. Oh, remember, if I see no coefficient, there's a 1 in front. And remember, in each term, we have to pay attention to the sign in front. So I have a -1 plus another -1 plus another -1. When I simplify this, I get a -3r. Last, I have d plus d plus d plus 5 minus 2. Well, I have to remember, like terms have the same variable raised to the same power. Well, here's a 1d, a 1d, and a 1d. All three of these have the same variable raised to the same exponent. Remember, when I do not see an exponent again, we have the secret ninja 1. Each variable here is raised to the power of 1. So I have 1d plus 1d plus 1d. That gives me 3d. So I've taken care of these. But now I take a look and I have a positive 5 minus 2. Well, I know that this is a constant and this is a constant. And all constants are like terms, so I can combine these two. 5 minus 2 gives me a positive 3. So when I simplify this expression, I get 3d plus 3. You can go ahead and pause the video here and try examples 1, 2, 3, and 4. And once you play the video again, you can check your answers. When I look at number 1, I look and I say, okay, well, do I have like terms and what are they? Well, I have an x, another x. All of them are x's raised to the power of 1. So I can combine all of these. That's 1x, 2x, 3x, 4x, 5x. When I simplify this one, I have 5x. When I look at 2, well, here's a 1y, another 1y, so I have 2y. And then 6, I have no like terms here, so I just have just 6. I can't combine that with anything. Number 3, I have 3m's raised to the power of 1. So when I combine that, I get 3m. Then I have a positive 5, which is a constant, and a positive 4, which is a constant. So I can add those two, and I will get 9. So I have 3m plus 9. The last example, I have 1, 2, 3, 4, 5, 6 n's. When I add those together, I get 6n. And then I have a positive 12 and a negative 8. So when I add those together, I get 12 minus 8. So I have 4 left over. This simplified is 6n plus 4. We're going to take a look at another example. We have 13x plus 7 minus 7x plus 2 minus 6y. So first, I'm going to look at my first term. I have a 13x. So I'm going to look at the rest of my expressions and say, okay, where are my other x's to the power of 1? Well, this is a constant. Here I have an x to the power of 1. Remember, when I am identifying my terms, we have to take the sign in front. This is a constant, and this is a y. So I have no more like terms. So I have 13x minus 7x. So I have here's 5x. Then I say, okay, now I have a constant of a positive 7, and I have a constant here of a positive 2. So I have 7 plus 2 gives me a positive 9. Then I look at my last term. I have a negative 6y. I have nothing to combine this with. So I just bring it straight down, and I have negative 6y. This is my simplified expression, 5x plus 9 minus 6y. This is the same problem that you were looking at before. I'm just going to show you another strategy for doing this. Next year, you will see this strategy a lot with Miss Virgil. She really enjoys using the T-charts. So the way the T-charts works is I say, okay, what type of terms do I have here? Well, I have an x, I have constants, and I have a y. So I'm going to create a 3-column T-chart. And I say, okay, well, what do my terms look like with the x? Well, I have a positive 13x, and I have a negative 7x. All right, so I've used these. My constants, what do my constants look like? Well, I have a positive 7 and a positive 2. My y's, what do I have for my y's? Well, I have a negative 6y. And now all I do is I combine each column. So I say, okay, well, what is 13x minus 7x? Well, that gives me a positive 5x. What's 7 plus 2? That gives me positive 9. And then 6y, there's nothing to combine that with, so I just have 6y. Notice I get the same answer as before. You can use either strategy. You can just circle or square the like terms and combine them, or you can use a T-chart and then combine each like term. Okay, here we have another example. We have 5xy plus 7y minus 2xy plus 8 plus 3y. So I look at my first term. Here I have a 5xy. So I need to find, okay, well, where are my other xy's? Here I have a negative 2xy. So I say, okay, what is 5xy minus 2xy? That's 3xy. Then I go ahead and I take a look at my second term. I have a positive 7y. Then I look and I say, okay, do I have any other y's? Well, here I have a positive 3y. So 7y plus 3y will give me 10y, a positive 10y. And then lastly, I have a constant, which is a positive 8. I have no other constants to combine it with, so I just write my plus 8. So this is, again, one way of doing it, identifying my like terms like this. Or we can go ahead and we can do the t-chart. I say, what do I have? Well, here I have an xy, and that is a 5xy. Here I have just a y, and that's a positive 7y. Then I have a negative 2xy, so it's going to go under my xy column. Then I have a constant of an 8, so I'm going to make a column for my constants. And then I have a positive 3y. Now I can go ahead and I can combine each term in my column. So 5x minus 2y, or I'm sorry, 5xy minus 2xy, which gives me 3xy. 7y plus 3y will give me 10y. And then I just have a positive 8 left. So I tag on my positive 8. Okay, now we have 8y plus 12x minus 19r plus 5 minus 6k. So I look at my first term. It's 8y. I say, do I have any y's? I do not. So I have to keep my 8y. I move on to the next term. I have a positive 12x. Do I have any x's? Nope. So I have to keep my 12x just like that. Then I move on to my next term, and I have a negative 19r. Do I have any r's? I don't. So I just add on my negative 19r. Then my next term is a plus 5. Do I have any other constants? I do not. So I just add on my 5. And then my last term is a negative 6k. I don't have any other terms with a k, so I have negative 6k. Because there were no like terms in this expression, I can't simplify it. It's already in the simplest form. So if I were asked to simplify this expression, it would be written the same exact way, because there is no way to simplify this anymore. It is already simplified because there are no like terms. So when we go ahead, let's take a look at our other example. We have 9f plus 7f cubed minus 7f plus 2 minus 6f cubed. So again, we're going to take a look at our very first term. We have 9f. Then I look and I say, okay, do I have any other f's? Well, here I have an f, but this f is cubed. It is to the power of 3. I need to remember that when I just have a number, just a variable, and I see no exponent, the exponent is really 1. So f to the power of 1 is not the same thing as f to the power of 3. So these two are not like terms. I look at my next term, and I have a negative 7f. Well, this f is also to the power of 1, so these two are like terms. I have a constant, and then I have an f cubed, or f to the power of 3 again, so these are my only two like terms. So I have 9f minus 7f, so when I combine them, I get 2f. I take a look at my next term. I have a positive 7f cubed. So I need to look and say, do I have any other f cubes? I do. Here I have a negative 6f cubed. So when I combine 7f cubed and negative 6f cubed, or 7f cubed minus 6f cubed, I end up with just a positive 1f cubed. But remember, I don't need to put the 1 in front. Then lastly, I only have one term left, and it's my constant. So I'm just going to add it on to the back. Now let's look at our next example. This one, we have 9r plus 3t minus 4r plus 8r cubed, or squared, minus 3r squared plus 12r to the power of 4. So again, I'm going to take a look at the very first term. We have 9r. I'm going to look for all my other r's to the power of 1. This was t. Here I have r to the power of 1. Remember to take the sign in front of each term. Here I have r squared, and r to the power of 4. So I can go ahead and combine these. I have 9r minus 4r. So I'm left with 5r when I combine those two. My next term is a positive 3t. Do I have any other t's? Any more variables of t? I do not. So I'm just going to add my 3t here. My next term is a positive 8r squared. I'm going to look and say, do I have any other r squares? Well, right next door I have a negative r squared. So I'm going to go ahead and I'm going to combine these. 8r squared minus 3r squared gives me my 5r. So a positive 5r squared. Then I take a look at my last term, and I have a 12r to the power of 4. I have no like terms for this one, so I'm just going to write it down in my expression. So when I take this expression and simplify it, I end up with 5r plus 3t plus 5r squared plus 12r to the power of 4. Go ahead and pause the video here and go ahead and complete these 8 examples. Once you're done, go ahead and play the video again and check your answers. Okay, for the first one, I can combine this 4x with 3x, and I get a 7x. There's nothing that I can combine this negative 3 with, so I'm just going to add it to the end. For our next one, we have 5y plus 4 minus 2y. Well, 5y has a like term. Here I have negative 2y. So 5y minus 2y gives me 3y. And I have a constant left, so I have plus 4. For this one, we have 8y minus 7 minus 4y. My first term, I have an 8y. And when I look back here, I have another y. So 8y minus 4y is going to leave me with a positive 4y. Here I have a minus 7 or a negative 7. I have nothing to combine that with, so I'm just going to add it to the back. Lastly, I have a 7z, and I notice I have another z to the power of 1 here, and I keep the sign in front. So I have 7z minus 2z, which gives me 5z. Here I have a constant of 9 and a constant of negative 2. And I know that all constants are like terms, so I can go ahead and combine these. 9 minus 2 will give me a positive 7. Let's go ahead and look at the last 4. So here we have a 5, which is a constant. So I'm going to look at my expression and say, do I have any other constants? I do. I have a negative 4. So 5 minus 4 gives me a positive 1. Then I have a positive 11z and a positive 6z. When I combine these two, I get a positive 17z. That's a z. Sorry. Okay, here I have 8g, and I look, do I have any other g's? Any other terms with g? Here I have a minus 3g or a negative 3g. So 8g minus 3g will give me 5g. Then I have a constant of a positive 10 and a constant of a positive 7. So when I combine those, I get a positive 17. Here I have a constant of 12. I look, do I have any other constants? I do. I have a negative 5. So 12 minus 5 give me 7. And then I have a positive 6g minus 4g. So I am left with a positive 2g. And then now our last one, I have 27, which is a constant, and I have another constant of negative 9. So 27 minus 9 is going to give me my 18. And then I have, sorry, I couldn't see anymore. I have a positive 3r plus 5r, or 15r, I'm sorry. So that gives me a 18r. And then here we had these two. And that gave us an 18. So when this one is simplified, we have 18 plus 18r.